Hello everyone, this is Omri and we are going to do a review of FQL, Functional Query Language. My personal favorite of CS Saturdays that happened during week 2. Top one for sure. So, starting off, in general, FQL, we're building a database management system, or a toy one, but we're building sort of our own version of Postgres. And the core of it starts with this idea of the table. The table is a class that's going to represent a certain folder. If we look at the test specs, actually let's skip ahead a bit. Notice that on line 49 we're going to see new table, film database, movies table, which points to a certain folder that has JSON files in it. Then we can call a read method on that, and that comes back with an object. And for reference, let's just look at what we are reading there. So here's the code to notice. And here's the file in question. So this is text. This is text stored in a JSON file. And we need to now create a class that has some kind of read method that will get us that back. And also we're going to use some utility methods. We're going to make some class methods as we go. So I'm actually going to convert this into a class. Let's do class syntax for this. And we're going to have read. We're going to have a constructor. I happen to know in our trajectory we're going to have get row IDs. And then we're going to have two static methods, or class methods. File name, or to file name, and to ID. The point of these being that they can take a string that represents an ID and convert it to a file name, or a string that represents a file name and convert it to an ID. Here's an ID, here's the file name. All right, and the ID versus file name distinction is not terribly large. So an ID is actually just, or a file name is actually just an ID plus .json at the end. So the ID might be, quote, 0004, and the file name is 004.json. And going the other way around, if we have 004.json and we want to get 004, then we're going to want to slice that string. And we can slice it from 0 to, let's see, 1, 2, 3, 4, 5, from -5 from the end. So start at 0, go until 5 from the end, and return that thing. This also, by the way, I haven't filled this out yet, but this takes a folder path, and we're going to store that folder path. Like that. I'm going to give it an underscore here. We'll talk about that in a second. I'm going to start unexiting some of these specs so we can see how we're doing. Okay, so to file name, to ID, and the constructor are working as expected. Before I go on, this syntax with the underscore, we're about to use it. It is not terribly important. So the underscore is just an idiomatic way of, in JavaScript, of saying this is an internal property. So if somebody else were using this table class and they saw that table instances had an underscore folder path property, they would know, or if they knew that idiom, they would know that the underscore means this is internal. You don't have to worry about it if you're using the library. This is just something that we put there so we could help ourselves build it. Now, read takes a row ID, or let's call it an ID, and then it comes back with the row data. So to do that, we're going to need to do an fs read file. And for this workshop, we're using fs read file sync. We're using a version of the read file method that comes built in with fs that is synchronous or blocking. And this is to avoid the complication of async execution flow that we're not trying to focus on. So that means we can take the folder path that we already have, and we can concatenate it with having turned the ID into a file name. Now this is going to give us our file contents. And that's not quite what we want. If we notice closely, the file contents that we have, this is actually just a string that will come back, formatted as JSON. But what we want is an object. And the method to convert that string into an object is json.parse. So this gives us back our actual row data, as it were. And since I'm just about to return it here, and we'll name the variable. I was thinking of getting rid of it, but this should be fine. So that's the general idea. Read the file based off of the table's folder path and a file name version of the ID concatenated together. Oh, almost forgot something important. With a slash, and we'll actually fix that in a little bit in a second. Then parse that using JSON.parse, and that's going to give us an object that we'll come back with. Let's see how that does. Oh, oops, that was the wrong one. But we'll actually solve this one next. So this one is telling us that we're getting an error, no such file or directory, when trying to open film database 0040.json. So this is because there is no such movie, there's no such row. And the specs tell us that instead of an error, we should actually return undefined. So what we're going to have to check is, does the file exist before reading it? So if it, let's say, does not exist, then we are going to return undefined. And the way we determine whether it exists is there's actually an fs.exists method, and we're going to use the blocking version on this same file path. And there we go. Now a couple things. One, we just copy and pasted. So this might as well be a variable. Let's cut it out. Call it file path. And use it in both places. Cool. Our code is still passing. Now, let's go ahead and, you know what, I've probably got to make it easier on my linter. Let's go ahead and refactor this a little bit. So this slash is fine. This is going to take the folder path plus a slash plus the file name. But it's only going to work for operating systems where we use forward slashes. If we were on a Windows machine, this might be a backslash, or who knows what it might be on some other custom world operating system. So if Node actually comes with something built in for this. There's this path module. And one of the things it can do is path.join. So we can just pass it comma-separated parts of a path, fragments of a path, and it will concatenate them together with the operating system appropriate character, like slash, forward slash for Unix or backslash for Windows. This should still work. So it's not like it was failing when we fixed it, but I just wanted to show you all path.join and talk about why it was useful. Let's go on to get row IDs. This takes no arguments and needs to return an array of all of the IDs. Now we can use fs_readdir_sync to get an array of the file names, and we need to pass that the folder path so it knows what directory to read from. So readdir is read directory or read folder. And now that we have the file names, we want to convert those things into IDs. And a nice method for doing so is map. I'm actually going to capture this and then return it, just so it's named, so we can easily talk about it, but we don't have to. File names.map. Now, for each file name, we are going to call toID on it, and that will give us an array of the IDs that we got from the file names. Let's see how that's doing. Yes, that's doing what we want. Only I want to talk about how we could make this even shorter. Well, first of all, it's a single line, which means that this is a good candidate for a single expression arrow function. So that looks like this. We take away the curly braces, we take away the return statement, and there's an implicit return now of just the thing to the right of the arrow. You know, even more than that, though, we could also go ahead and replace this anonymous function with a function we already have. So I'm going to do this in 2 steps. I'm going to call this convert file name to ID right here. And that's all I've done is name it, and now I'm going to use it right here, convert file name to ID. Cool. So what we've done is we pass in a function that takes a file name and calls table.toID on that file name. And this will still work. There's nothing, all I'm doing is naming it, because the next trick I want to show is kind of interesting. Now, if we look at this convert file name to ID function, it takes one argument, file name. It calls table.toID on that argument. Well, if you'll notice, we already have a function that does that. If we look at the static toID method, it takes one argument, file name. It returns that file name converted into an ID. So we could also equally just say equals table.toID without invoking it, as in converting a file name to ID is equal to, it's the same as just the table.toID function, and this would work. And because of that, we also don't even need this constant. We could just say table.toID. And that's a really cool thing that is called point-free notation, where we don't declare a function, we actually use an existing function and pass it in. This can seem very weird because we're not used to doing this. We're not used to having a defined method that we pass into map. We're used to defining an anonymous function here. So I encourage you to take a look at this and research point-free programming and take a look at our functional programming series on point-free from the junior phase if you're curious about that. And if you don't know where to find that, feel free to reach out to one of the instructors. Sweet. So now we're going to go on to the FQL get method. Now that we have a table, so this was in charge of the persistence, talking to the file system. FQL is a class that's in charge of the query interface. Things like limit, select, and, notably, which we're about to define, get. So get is the thing, it takes no arguments, but it runs the query. And the constructor takes a table, and as before, we're just going to keep track of what that table is. We'll use an underscore to indicate that this is an internal property, that anything outside of the FQL class should not need to access it. Here's get. So get, when it runs, should go down every element, every row in the table, and read it and put it into an array. So the way I'm going to do that now is a little bit long-winded. I'm going to define an array. I'm going to go down for I is 0 while I is less than, and here's where we're going to need the row IDs. So this is this table get row IDs. Cool. So line 9 gives us the row IDs, and while this incrementing number is less than that length, we plus it. So we're going to try and go down all of the rows. And so each ID is going to be row IDs I. And now we can do this underscore table read on that particular ID, and that comes back with row data. Once we've got that, we can push it into rows and return all of it at the end. So this is us executing a query that would just always return everything for now. The sort of default get me all the data from this table kind of query. Let's see how it's doing. Yeah, so this is doing what we want. And before we go on, there are a couple things I want to say and then a couple things I want to change. You may have noticed that what we could do instead is a map here. We could do this table get row IDs dot map, and inside the dot map, read all of the IDs. Read all of the IDs, convert them into rows, and return it. So that would look something like, instead of any of this, it would be a single line. Return this table get row IDs map, convert each ID into a row by reading it, and that's it. Done. So that single line, this is, once we understand how to use map well, this is much more readable, in my opinion, than the code above. Whether it's readable to you or not, that's perfectly up to you and not something that I think you should feel one way or the other about. But it's certainly shorter the way we have it here. I'm actually going to stick with what we've got because I know coming down the line, this is going to be a more useful structure. We are actually going to need to break out of this loop, which is not something we can do in map. That's if we hit the limit. And we're also going to need to filter it and say only certain rows get into it when we get to where. So I'm going to leave this structure the way it is, even though it's a little more verbose. But I am going to make it a little bit better. So right now we're using a loop to go down every element of an array. And in fact, there's already a good loop for that. If you're not familiar with for of, well, you're about to be. So instead of a for loop with 3 separate statements, the starting condition, the is less than, the plus plus, we can instead do something like this. So here we say for element of, and then the thing to the right should be an iterable, in this case an array. So for each element of this array, and now we've captured that element as the variable ID, we go ahead and read it. And this will rerun for each thing. So for of loops are especially good when you want to go down every element of an iterable, which is a certain protocol in JavaScript, but in this case, it's useful for arrays. For every element in an array, we can do this. And that just saves us the headache of needing to type out the for let I equal 0 while I is less than the array length, I plus plus kind of deal. And it'll still pass. This was a for of loop. Let's go on to count. So count is a method that we might as well reuse our own get method for now and return the length. There are some reasons this might not be ideal, but I think for now this will be okay. So here we're saying use your own get method and then get the length of the array that comes back. That is the count of the rows that match the query. The nice thing about doing it this way is that later when we change how get works in order for the query to run differently for limit or where or select, count won't need to change. Count will still just call get and then the length. We won't need to update both of these when we update the query logic. That has been part 1. We are going to go on to part 2 in the next bit.